Hello, friends. My name is Lakshmi. I'm from Raj Academy. I'm a professional trainer. So here we are going to see just one sample demo class. I have taken Unit 7, Data Structure and Algorithm Concept. It's a very important topic actually, unit. So here we are going to see today is a tree model. So what is tree? So here we will get many questions from tree concept. So tree represents a node connected by edges. So normally how will be tree here? Here diagram have given actually. So here the edges and vertices, connection of edges and nodes are. So we will discuss here binary tree, what is binary search tree as well as AVL tree today. So first one, binary tree. So binary tree is a special data structures used for data storage purpose actually. So the binary tree is a special condition. Each node can have a maximum of 2 children. For example, here you can see A means here B and C. So like this B means D and E. Then binary tree has benefits of both order array and a linked list. Of search is quick in sorted array, and we can do operations insertion and deletion also fast manner. In this diagram, we have to know which one is the root. This is called root. And these are the levels, level 0, level 1, level 2, and level 3. So here we have to know the levels. What are the levels? So depends on the level, we will get calculations actually. And which one is the parent node and which one is the child node and which one is the leaves and which one is subtree. This is called subtree actually. And leaves node. This is a leaves node. So these are the concept first we have to know from the diagram. Next one, binary search tree representation. So how it will be is a binary search tree. Binary search tree exhibits a special behavior. A node's left child must have a less than value. So left child, for example, here this is root 27. In this left side, it must be less value compared to this 27. It must be there. Okay, so 14 here. And right side, it must be the higher value compared to root node. So this is the actually rules are. So the parent child and the root node's right child must have a greater than parent value. Okay, so here you can see 14, here 10, here 14 greater than value. This is a 19. So like this, we have to insert the values. For example, I'll write some of the numbers. For example, 6, 10, and 4, and 3, and 17, and 19 or something, or 19. How we can insert this value? First one, you can insert, this is the value, first one. Yes, just you can take. Next one, 10 means actually 6, it's a higher value compared to 6. So 10, it has to come in the right side. Okay. So next one, 4 means here left side it has to come. So 4, it has to come here. Okay. So next one, 3 means actually where it has to come. So less value compared to 4. So here it has to come 4, 3, this number. And 17 means it's a compare then this is 10, then compare the highest value. So 17 it has to come here. And 19 is compared to 17, that's the highest value. So like this, we have to insert the values up. So we will get questions from binary search tree maybe, and strictly binary tree and AVL tree and max heap, and some of the main concepts are there. So binary search tree is one of the important concept. Just they will ask how they are going to insert the value. After inserting, which one is the right side maximum value? Like this we will get question. Okay. Okay, so next one, AVL tree. What is AVL tree? AVL can be defined as a height balanced binary search tree. The same thing, binary search tree depends on which we have seen already. The same thing, but is a height balanced tree. That's all. Okay, so here height balanced just formula, balance factor equal to height of left of k minus height of right of k. So here we have to mention one node. We can get 0, 1, minus 1. That's all. If we will get 2 value, we have to make it as a balance factor. Again, I'll tell you, we have to get answer while doing the calculation, balance factor calculation. We have to get 0, 1 or minus 1. If we will get other numbers apart from this, automatically we have to make it as a balance tree. So we have some rules and regulations to make the balance tree in AVL. Okay, that we are going to see. First one, if balance factor of any node 1 means, it means the left subtree is a one level higher than right subtree. That's just they have given meaning. If balance factor any nodes is 0 means the left subtree and right sub this tree is a both equal height. And if balance factor any node minus 1 means, it means the left subtree is one level lower than right one. Okay. Next one. Here, just see this diagram. It's very important diagram. First of all, see this number 100. Here 50 less than number. Here 150 greater than number. Here 50 less than number 25 compared to 50 greater than 75. And 75 compared to 65 less than, this is 85 greater than. So what is the meaning actually? That is a binary search tree model. Okay. Now we are going to make as a first balance we are going to check. So here we have to check left subtree minus right subtree. Now we can see this one for 100, 50 maximum height we have to take. What is the maximum height? 1, 2, 3. So left side maximum height 3 actually. And right side 1, 1, 2. So minus 2 equal to 1. So if 1 is it's a correct balance factor, yes, correct, no problem. Okay. Next one, this for this value we have to check. This, what is this height? 1. Okay. What is this height? 1, 2, maximum height. So minus 2 is equal to, what is the value? Minus 1. So minus 1 also, this is a balance factor. It's not a problem. Next one, for this one, you can take 1 minus 1. So 1 minus 1 equal to 0. So 0 also balance factor. So whenever we will get 1 minus 1, 0, this is a balance factors only. So not a problem. For this, no left, no right. So 0 only. So for this one, 1 left, 1 right. So 1 minus 1 equal to 0. So for this one, 1 already we have calculated. For this, no left, no right, 0. Here 0, here 0, here 0. So in this AVL tree, everything we have calculated. Now we got everything is a balance factors only. 0, 1, minus 1 only. We didn't get any 2 or 3, any numbers. If we'll get 2, 3 or some other numbers, so we have to apply LL rotation, RR rotation, LR rotation, RL rotation models we have to apply, and we have to make it as a balance tree. Okay, this is a huge portion actually. Just this is a sample class I have taken. I hope is it clear, this one. Thank you, all of you.